We're going to look at permutations and combinations today. This is probably something that you've probably seen before, probably not a whole lot though. So if you have or haven't, not a big deal. We're going to kind of start from the beginning. What you see on the page is a set of formulas. This is called a combination formula and a permutation. So NCR and NPR, if you have a scientific calculator, you have the ability to perform these calculations in your calculator without the need for all of these formulas. And that is perfectly fine for you to do that. If you are using a calculator, what you're looking for is a PRB button on your calculator. If you have a TI-84, what you want to do is you're going to press Math, right? That's on the left side, about the fourth button down, and you're going to go over to PRB, okay? If you have a traditional scientific calculator, for the most part, you're going to be looking for a PRB button. If you press that, you're going to notice probably three things. If you have the TI-84, you're going to get more, but the only thing we're looking for in this case are these three. It's NCR, NPR, and then the Factorial button, okay? These two clearly are the most important. And I'll show you kind of how to work through that, but let me explain the formulas just for a minute, and then we'll talk about how to use the calculator and how to compute some of these options. First of all, N represents the number of choices you have. R represents how many things I'm going to be choosing from those choices. So let's suppose that I had 20 people in a room and I wanted to pick a group of 3. How many different ways could I do that? You would say that's 20 choose 3. And so you have 20 choices, and there are 3 choices to pick from. Now, whether that's a combination or permutation hasn't really been determined yet. I just told you you're going to be choosing. The question would be, does the order matter, right, the way that I pick them? Does the 3 people make a difference? Or is it just a group of 3 and the order that I pick them in is really not important? For example, if I told you that we're just going to pick 3 people as a group, and I didn't say anything, if I picked, 1, 2, and 3, or 3, 2, and 1, then they're the same group of people. It doesn't really matter which way. That's called a combination. The order does not matter. But if I say that, well, the first person I pick is going to be a president, then the second person is going to be the vice president, and the third person is going to be the secretary, then those 3 groupings of people, right, the different ways I can do it, that's 6 different ways actually, every person will be a different president or a different vice president or a different secretary, any one of those, then that's a permutation. Each one of those is a very different set. For example, if I use numbers, the numbers 1, 2, 3, 1, 2, 3, or 3, 2, 1, or 2, 3, 1. These are different sets of numbers. Now, to us, those are different numbers, though they would be permutations. Each one is per individual. But if I said, well, let's just group the numbers 3, 2, and 1 together, and it doesn't matter the way I wrote them down, then all of these would be exactly the same combination, right? It's just the numbers 3, 2, and 1. I don't care how you write them out, what order you put them in. If it's a combination, then it's that all represents just one combination of numbers, okay? The factorial button you see here in the formulas are something like this, right? Factorial means it's that number times every whole number all the way back down to 1. So if I'm going to use the formula to do what I did earlier, I said, let's pick 20 out of 20 people, and let's say we're going to make it the president, vice president, and all that stuff. Then the formula, if I were to work this out by hand, looks like this, right? It's n factorial, so 20 factorial divided by 3 factorial times 20 minus 3, which is 17 factorial. And so if I needed to work this out by hand, I can say that, well, 20 factorial is 20 times 19 times 18 times 17 all the way back down to 1. I'll just stop right there, right? And then 3 times 2 times 1, and then that 17 would be 17 times 16 times 15 factorial, right? All of that. But we really know that this is just 17 factorial. So that cancels out with this one. 3 can go into 18 6 times. 2 can go into 20 10 times. You get the point, right? So this really does become just 10 times 19 times 6 as a solution. Now, I don't really expect most of you to do it this way. What I do think you should do is to find your calculator. Now, if you have a TI-84 that's relatively new and it's been updated, then what's going to happen is when you type this in, let's say you've chosen the permutation formula, what's going to happen is it's going to give you these little boxes, P, and then it'll give you another box here. What you can do is you can go in here and you can put in 20 and 3 after the fact and then hit enter and it'll give it to you. Now, if you have an older TI-84, or one that hasn't been necessarily updated as much, or if you have a traditional calculator, what you're going to want to do is do this. You're going to do 20, and then you're going to go in and you're going to get NPR, and then you're going to go in and hit 3. And then you can hit enter, right? And you do it in that order, and it goes that way. So if you don't get these little boxes like this, then you're going to have to do it in separate pieces, so 1, 2, and 3, and that's how it will work. Super easy, super not a big deal. Go through it that way. All right, I'm going to look at some worksheets that I want to talk about. Here up top you have the 7, choose 6 when permutations. In 3, 4, 5, and 6, it's asking us if we want to say, is this a permutation? Is it a combination? Then it wants us to actually calculate it. So here in number 3 we have, we're looking at getting 4 out of 9 students will ride in a car instead of van. So does it matter the order that I pick those 4 students? And you would say, no, it's just the group of 4, they're going to be in the car. The order that you pick them is irrelevant. So this would be 9 choices total. I'm going to be doing a combination because the order does not matter. 9C4. So this is a combination. I'd work that out, and you can do that in your calculator. The answers on the next sheet. You can look those up when you kind of work this out on your own. Okay. Look at number 5. The student body has 120 students, wants to elect a vice president, president, and secretary. So clearly that does matter. So this would be 120. This is a permutation here, and then I'm going to be picking 3 people out of that. And I would go ahead and work that out and get the numbers there as well. Okay. The only really other thing that we talked about here is 7, 8, 9, and 10. And specifically, I really want you to focus on numbers 7 and 8. I'm really not worried about 9 and 10. 7 is about sample space. Okay, that's this word here. Sample space is a definition. The definition of sample space is the list of all possible outcomes. And literally a list. It's not a math scenario. For example, if a bag contains 1 red marble, 1 green marble, and 1 blue marble, then if you pick a random marble to play with and then your friend picks a marble, then what are the possibilities, right? You're going to be picking 2 different marbles from the bag. Well, there's only 3 choices. So you could pick a red one, and your friend could pick a green one, or your friend could pick a blue one. You could pick a blue one. Your friend could pick a red one or a green one. You could pick a green one, or your friend could pick the red one or the blue one. Now that makes a big difference, and the order here is important because it's 2 different people. It's not like you picking 2 marbles and looking at what color is. So the order here is important. For example, getting a red first and a green second, like this one, and getting a green first and a red second, although those are just picking a red and green marble, 2 different people have those different colors. So each one of these is a different one, right? So set notation just means, I'm not really worried about the part. Just writing down all the possibilities. For example, if I roll a die, the sample space is 1, 2, 3, 4, 5, 6. That's the full sample space. Number 8, it says an ice cream shop offers single scoop waffle cones or bowls. There's 4 flavors: strawberry, chocolate, vanilla, and mint chocolate chip. What is the sample space here? Well, you could have the waffle cone with strawberry, the waffle cone with chocolate, the waffle cone with vanilla, and the waffle cone with mint chocolate chip. But I can also have the bowl with strawberry, the bowl with chocolate, the bowl with vanilla, and the bowl with mint chocolate chip. This is a list of all the possibilities. This is what we call the sample space. Okay? If you got those things and you understand how to do these permutations, combinations in your calculator, then you have that is really the most important aspects of this lesson. If you have questions about this or can't quite get it worked out, let me know. I'm going to post this worksheet along with the key so you can check it out. Let me know if you have any questions. Have a great day.